All right, good afternoon, everyone, and welcome to our webinar today, which is entitled Refine and Validate Designs with Simulation. And in this webinar, what we're going to do is we're going to take a closer look at the Ansys Simulation extension tools that are available for Creo. My name is Rob Romanowski. I'm the Director of Sales Operations with 3HTI. And leading the overview and the demo today is Paul Dye, an application engineer with PTC based out of Pittsburgh. And they're all very excited about Kenny Pickett.
Not all.
My son is. He loves Kenny Pickett. And I'm on the other side of the Commonwealth. So anyway, we're going to let Paul lead everything today. But if you have any questions, please put those in the chat. We'll try to answer them as we go, but we will definitely answer them at the end. And Paul, how long do you think this overview and presentation will take?
I think we'll be in and out probably less than 20 minutes.
All right, good deal. We normally like to keep 20 minutes. Last week was Creo 9, so we knew that was going to be a little longer. So without further ado, Paul, take it away, my friend.
Yeah, thank you, Rob. Always happy to be on. And it is a rare sunny day here in Pittsburgh, so feeling good. And always happy to talk about anything related to simulation in Creo. A lot of great things going on, especially with Creo Ansys Simulation. If you haven't seen into this, we're definitely going to go through and talk to a lot of different capabilities. You're going to see a lot around it. Go through and cover that, show what it looks like in the context of Creo. If you have any questions, feel free to drop them in. Always happy to go through and answer any of those. And yeah, happy to be here. So let's go ahead and dive into things. And before I start into talking some of the main capabilities, a lot of times I like to go through and really lay the groundwork by going over some of the main challenges that we typically see out in the industry around people that want to work around simulation. And starting into it, you need to understand how your products are going to perform in the field. You need to understand how products react in different situations, how they perform under normal operating conditions, and you need to be able to incorporate that into the way that you do design. And looking at analysis, it's a great tool in general for getting that type of feedback, but typically your designers, the engineers, they honestly just don't feel like they have a lot of times the expertise that you really need to run simulations, especially as you're beginning to refine things, as you're getting further along into the design process. What normally happens is you have an engineer, they either have to consult an expert on the team or they need to send it out to a third party to do analysis. And if you've ever done that, it can be very time consuming. It can be very expensive to do that. Most times it takes multiple different iterations back and forth between the designer and the analyst who's running that analysis before you end up getting to a verified product. It's generally very disruptive, slows down your design cycles. A lot of times leads people to avoid it entirely. So there's definitely an issue with the way that analysis in general has been done up until this point. And what we did was we really took these different challenges into consideration and we partnered up with Ansys to provide a solution within Creo, and actually a couple of different solutions. The first tool that we built out as part of the partnership with Ansys was Creo Simulation Live. If you haven't seen this before, it's essentially a tool that we use to integrate their Discovery Live engine that they have with Ansys and put that natively into Creo Parametric. It's something that's really used as a design tool for designers to build out designs a lot better right from the get-go, right from the start of the process. It's typically used maybe 5 to 10% of the way into a design and honestly used all throughout the design cycle, really to do more design work, not really your traditional type of analysis. And what we're doing now is we're really taking the partnership with Ansys a step further and working now with Creo Ansys Simulation. This is taking their high-fidelity Ansys-powered solvers and putting them into the hands of the designer or engineer. So whereas Creo Simulation Live won't get you to more of those refined convergent values, really what we're doing with Creo Ansys is taking it that next step and really giving you more of a validation tool, but at the same time, still allowing you to use this throughout the design process. It's not disruptive and it's not something that's out of the scope of what a designer would want to use. And first and foremost, what this is a comprehensive tool for doing linear static analysis for multiple different scenarios for structural, thermal, and vibration use cases. And you'll see this throughout the demonstration, very simple to work with and work around. You have a simulation tree where you set up and manage all your different studies that you're working with. You're even able to copy and paste loads and different constraints between your setups. Makes it very fast to go through, try out lots of different use cases, which you oftentimes need to do whenever you're working with this throughout the design process. Setting up the studies is very straightforward. All the loads, all the constraints really allow you to set up very realistic situations in a way that works for your designers or your engineers. If you had a simulation setup that was done over in Creo Simulation Live, if you do work with that, that could be used as the base for the study. That could be applied directly in Creo Ansys Simulation as well. So working between those two is a breeze. Another great capability that we have within this tool is automatic meshing and contact handling. With that, there's really no need to have any prior meshing expertise in order to build out very accurate meshes very quickly. You do have more advanced options for controlling the mesh or refining it in certain areas if you do want to focus in on that, but different options there. And also handling contacts is done in the exact same way. You have the ability to let the system automatically define contacts for you, but you still have the ability as well to define manually those contacts if you need to. And again, it's Ansys. The same exact technology that's used in their platform is being used here to give you the highest fidelity results. And the results that you're getting back are going to be very visual, very interactive. You have a fully customizable results legend to display both basic and more advanced results. You have the ability to query anywhere on the model, interrogate certain spots that might be interesting. Simulation probes can be placed to monitor different values. Even if you make changes to the model or the study, those can all be updated on the fly. And possibly the greatest thing about this tool is the integration with Creo. Everything that you're doing is in the same consistent user interface. So if you've used Creo, you're pretty much halfway there to already knowing how to use this tool. Another thing here with this is there's no data translations. The model, the geometry that you built out, it's the same model that you're using in Creo Ansys Simulation. Like I mentioned, even if there's changes to the geometry, full associativity down the line to your analysis information. And one thing to mention here too, if you did want to take the analysis even further and expand on the capabilities that we have in Creo Ansys, you could have the option to export out the simulation study to be used in the full Ansys Workbench platform. Again, more likely being done by the dedicated analysts or the experts, but you do have that option if you wanted to maintain that workflow over to the final validation. All right, so with that, we'll go ahead and take a second if we have any questions, but with that, we can go ahead and dive into a demonstration so you can see what the workflow looks like in the context of Creo. Again, if you do have any questions, feel free to drop that in the chat and we can go ahead and answer those at any point. All right, so with this, we can go ahead and get started. So for our demonstration of Creo Ansys Simulation, I'm going to be using a data set from one of our customers, Royal Enfield. Specifically, this is the rear arm assembly off of one of their motorcycle designs. Like you can see, we're going to stay right here within Creo, and we're just going to work with a standard structural analysis. Getting into it, we have some base forces over on the right-hand side of the model, possibly wherever it's connected back in with main assembly. We have a displacement constraint laid out. We could also go ahead and add in another constraint so you can see what this would look like to add one in. We'll do this with a cylindrical constraint. Very straightforward to do. Just select on the surfaces that you want to constrain. Do that up at the top here as well. And we're good to go. So that's a lot of the main setup that you'll do in getting into a study is just say what materials that you want to have applied to your models, what are your forces and constraints, and you're normally pretty much good to go in terms of laying out the setup for the study. Once we do this, though, with this really being an assembly model, one of the main things we have to do is define the connections between the various parts. Again, we could define the contacts manually, or we could have Creo Ansys Simulation automatically detect those contacts for us as well. Another thing that we can show here too is working with the mesh resolution. So this is very straightforward to do. Essentially, you'll have a first initial resolution that you could lay out, but around this as well, if you do want to have a little bit more control over this, you could go through and lay out the global mesh sizes, just really allowing you to get to the different details that you want within that mesh resolution. All right, from here, we can go ahead and generate that mesh. And the mesh generation is run by the solver. So the time that it takes can depend on the size of the model, but we're always able to monitor the progress and the status of the mesh generation down here in the process manager. All right, and once that mesh is generated, we can go ahead and display that, check it out. And if we like what we got, we can go ahead and go back into the study and run the analysis. We could again use the process manager to monitor the status of the simulation studies that we're running. While it's running, it displays the number of processes that are running, as well as the ones that were completed for the current session. And again, the solver, the meshing technology that's used here in Creo Ansys Simulation, same exact technology that powers the Ansys Workbench platform. And that's part of the reason why it's so easy to move between the different applications. You bring your studies over from Creo Simulation Live, refine those results here in Creo Ansys Simulation. And if you wanted to export out to the full Ansys tool to further expand upon the capabilities, and probably more specific to the analyst. All right. You can see now that it was fairly quick to go through and run through the simulation. We can move over now and check out some of the results. And with the results, there's two main categories of simulation results. You have basic and advanced. So here in basic, you get things like your von Mises stresses, displacement magnitude, displacement in the different directions. We can see the results for those. And we can see that visualized up on the model here. We're getting a max stress of around 85 megapascals. So you can see it highlights the max area right on the model itself. We can take a look over on the other side of the model. Seems to be a little bit less than what we got in the first area. Now, if we wanted to get more specific information onto that area, we could do a simulation query that pulls up values at specific points in the model. And we're able to dynamically change that around to different points. Another option that we have here is the ability to place a simulation probe on the model. These probes exist as part of the analysis model. So these could update for different variables or result types as the study is being run. Or even if you make changes to the study itself, the value that you will get there is going to update, which you could do over in the simulation tree under the results tab right here. All right, and at any point, you're able to turn off those probes if you need to. Another area of interest that I might have here is the displacement in the model based on the loads that I have laid out. So I can go ahead and add this into my results and maybe have a contour applied to the model. And because we defined that after the analysis was run, we'll just simply update the results for the new things that we want to look at. All right, so once that's done running, we can go ahead and take a look at what we got. So you can see here on the model, we're getting around 0.02 for our max displacement. We could get an even better understanding of that by animating on the deformation, see exactly how the model reacts. We could turn off or on the mesh visualization if we'd like to. But this is looking pretty good. And what I want to do now is actually move on to refining the analysis a bit. Based on some of the initial results that we got back, I know the areas where I'm seeing the most amount of stress. So what Creo Ansys Simulation allows us to do is add in selective detail into that mesh and get even more accurate results in the specific areas that we want to define. So on my model here, we obviously saw the most amount of stress occurring at the outer surfaces of those brackets. So we'll go ahead and create a finer mesh in those areas. So what it's doing is overriding the global size settings that we initially set for the model and just allowing us to get even more detail into the areas that are important for us there. And it'll go ahead here and regenerate that mesh. All right, once that's regenerated, we can go back and display the mesh, see what we got. All right, and now down in those areas that we were working with, we have a much finer geometry in those areas of the bracket now. Okay, so I've gone ahead and refined the mesh based on some of my initial findings. So what I want to do now is rerun through the study. Again, we can turn back on that probe that we set from earlier and go back up to the top and run back through that study. And again, while this is running, we can open up the process manager, see exactly how far along the study is. If you're going to open up a breakdown of that progress, we can see that it shows the completion percentage for the mesh, shows the solve for the analysis itself, and then for the results that we want to display. And once it finishes up, which again doesn't take very long to do there, we can go ahead and look at our updated results. First thing we can look at is our von Mises stress. Go ahead and see what we got there. And looking at this, it's actually increased a little bit from where it was before. We can see that it's located in almost the same exact spot, but the value is increased. which makes sense as we got probably a bit more accurate result as we went through and refined that analysis. We can also go ahead and open up the probe that we had on the right-hand side of the model. See what we got there. That value is also increased a little bit. And really, that's the general workflow that you would follow for an end-to-end structural simulation. So very easy to set those up, get some pretty high fidelity runs through pretty quickly. I do want to touch here now on our next type of simulation, which is going to be more of a vibrational study. But before that, I could take a moment to see if there's any questions or anything that's came in.
There's a few questions. So one question is, if the mesh fails, or if and when the mesh fails, does it show where and why it failed?
Yeah, so there will be some diagnostics on the mesh itself. It'll go through and say what exactly did go wrong. In terms of whether or not it highlights the specific areas, I'm not sure. I could check into exactly what level of detail that the mesh diagnostics could get into, but it will help you to key into those areas and start to work to refine that to get it to run through properly. But in terms of the specifics, I could definitely look into exactly what it'll tell you back on that.
And can you also check the mesh quality?
That I don't know. I think I'd have to see what exactly you mean by mesh quality.
I mean, I would think that, you know, you can run the mesh automatically, and then as you inspect the mesh, you could manually make adjustments in areas that you feel might need it.
Yeah, for sure. There's definitely the ability to go through and visually inspect the model. Obviously, you can see based on whatever you set for those global settings, how it went through and applied those in the model. In terms of the quality, I'm not sure if that's more or less an objective or subjective topic, right? I'm not sure if there's any type of specifics that you would have around that.
Okay. So basically, this person who's asking seems like he's pretty familiar with Ansys, because he says with Ansys, you can check for quality of mesh.
Okay.
So he's asking, does it let you query the quality here too? And I would think that it should. There shouldn't really be a difference.
Yeah, no, I would have to check to make sure on that, but you can go through and check out specific areas of the mesh for sure. In terms of exactly what it means for the quality, there might be a difference between what you're able to do in the full Ansys tool and what's here, but I just have to see exactly what you mean by that whenever you're checking out for the quality of the mesh.
Okay. Now, another question, these are kind of generic questions, but they're really good questions. One is, can it run a nonlinear analysis?
No, so right now, everything in Creo Ansys is going to be static and linear. Anything static, anything linear for anything that you would run, either structural, thermal, or modal.
Mm-hmm. Last question, is this module embedded within Creo?
Yeah, so it is embedded within Creo. It is a separate extension, so it's not available out of the box. It is an extension and a license that you would have to activate, but it is embedded natively within Creo.
Yeah, that's a big deal because you don't have to export the file and then import it into, you know, a third-party tool.
Yeah, absolutely. So even though it
deal.
is an extension, it's still just another button within Creo, basically, that you click on, keeps the same model. And you'll even see as I go through and work with this model a little bit, you can go through and make changes and just dive right back into the study.
Cool.
Right.
All right,
Yeah,
we shall carry on.
Yeah, so we'll go ahead and
Good questions. Thank you.
Yeah, definitely. I mean, even good things for me to understand as well. So we'll definitely look into those too. All right, so next type of simulation that I'll run through here is going to be a modal or vibration study. Go ahead and activate that here. And again, what's nice about this, and like we mentioned from earlier, is you could actually copy and paste the constraints or any of the loads that you had over in the structural study. In this case here, we just want to take the constraints and paste them into our new setup. Very straightforward to do. From there, again, we can get our contacts detected, similar to how we did in the structural study. Go ahead and lay that out here. All right, and then we'll go ahead and set up the mesh for the study. And again, the workflow is pretty much the same up until this point. we wanted to get more of a higher fidelity run, we could go through and have a little bit more control over the specific size of that here. And now we'll go ahead and generate the mesh that we laid out. And overall, fairly quick to run through and do. And one thing to notice in the process manager is you can see not only the process that's being currently run, you could also get the full history of everything that we've run up until this point, and exactly when and how long each one took to run. And once that's been generated, we can take a quick preview and display that up on the model. All right, so with that, we can go ahead and move into some of the setup here for the actual study itself. This being a modal analysis, we'll specify how many natural frequency modes that we want to go through and solve for the study. On top of that, we can define what we want to view in the results. In this case, I want to see a contour plot applied for the first frequency mode. In fact, let's go ahead and do that for the second frequency mode as well. Maybe I also want to use a simulation probe that allows us to view a frequency table for all 4 modes that we want to be running. Go ahead and set that up here. And that's pretty much it. So with that laid out, we can go ahead and jump into the study. So again, some of the constraints that you might work with between the 2 studies would be pretty much the same as you would see in a structural study. You wouldn't be working with the same type of forces, obviously. It's a different type there altogether, but you can carry over anything that would be the same between the 2 studies. So this would be a pretty typical workflow that you would see either working from the structural side, taking this into a thermal study, or taking the next step further here into more of a vibrational study as well. And even with that, even with switching the type of studies, it's still going to be very fast to go through here and run that simulation. All right, so with our study complete there, we can go ahead and take a look at some of the results that we got. First thing I'm going to look at is our frequency table. You can see the natural frequency responses based on the constraints that we had applied in the simulation definition. We could also take a look at our contour plot for the displacement magnitude in our rear arm assembly. These are being taken from mode 1. And we could turn off or on the mesh. We could take it a step further like we did earlier and animate on that definition. Go ahead and do the same thing here for our mode 2. And immediate with this, we're seeing a much different type of deformation. So these contour plots, along with the deformation animation, really give us a much better understanding of how that model is reacting and probably how it would behave under normal operating conditions. All right, and now what I'm going to move into is kind of a bigger piece of this. And really the main thing that I've been touching on is based off of the results that I got from either the structural or the modal studies. What you could do now is go right back into the model, right back into your standard design environment, and make some changes in order to improve the design or just make some different refinements. The main area that I want to look at in this case are these brackets. It's where the max von Mises stresses are located. It's definitely a spot where I know I can make some improvements. This could mean a number of different things. It could mean, first and foremost, making a change to the length of the bracket, spread out the load a little bit. You could also try increasing the thickness. And one thing that I want to highlight here is that the changes that we're making tend to be more focused on refinement in this case. The assembly that we're working on is mostly complete. We're pretty far along in the process and really, again, focused more on validating that my model has been built out correctly. If you were working more towards the beginning or mid stages of the design, if you're making fairly drastic type of changes, it's probably something that would be geared more towards Creo Simulation Live. If you wanted to get more real-time, instantaneous feedback on how the model is responding. It's not to say that you couldn't still run these through in your Creo Ansys simulation as well. You definitely could. But this kind of spans a little bit more of that refinement stage, a little bit more of that high fidelity results that you want to get back. And we're definitely going to run these type of simulations through in Creo to make sure that it's been built out correctly, make sure that it's ready for manufacturing. And we can go back through and run the structural analysis again, see what we got in terms of changes here. And what's nice here is because we didn't change the context, we didn't change the constraints, any of the forces, we can just run right back through the same tests as we had before. But again, because we're rerunning the study, the results that we're going to end up getting back here, the ones that we're going to see, are going to be a little bit different than the first time that we ran the study, or at least they should be. And one of the biggest things to notice throughout really this entire process that we've done between each study that we've ran we never had to leave Creo one time. And that's a big thing, because what that means is there's no data translations. You don't have two different programs interpreting the geometry two different ways, right? We're able to stay right here within Creo, same easy to use interface that you're used to with Creo Parametric. So again, if I've already been working in Creo Parametric up to this point, really you're going to have a very easy time working with this user interface as well. It's going to be pretty much the exact same process that you've been used to. All right. And once our run is complete, we can see that it's built out the mesh, it's done the solving, calculated the results that we're looking for, and now we can go through and check out some of our final results. So go ahead and start here with the von Mises stress. And we can see right away that the von Mises stress has decreased pretty significantly from where it was. It was around 85 megapascals. We got it down to around 67 now. If we zoom in down here on our first bracket, you can see the load is stayed in the same place, and it's really functioning the way that we want it to. And then over on the other bracket, we can see here that our simulation probe has also updated for the new values. Despite the fact that the surface was changed, it still was able to update for that. But that's really everything that I wanted to cover here. This is the standard type of workflow that you'll follow in Creo Ansys Simulation. It's validation analysis done with Ansys Mechanical solvers, and again, all right within Creo. So good overview of what that process looks like. Really happy to go through and show a little bit about what we're really doing there. So before we go ahead and wrap up for the rest of the day, I do want to take a moment here just to touch on some of the main value that you really do get from working on what you're doing here. And first of all, Creo Ansys Simulation is really giving you a much deeper integration of simulation throughout the entire design process. It's no longer a disjointed system where you have design and analysis in two completely separate worlds. We really integrate the two very well together, so you can start enjoying the benefits of simulation right from the start of the design. I mean, shorter development cycle times, less time sending a model back and forth through a lot of different iterations, and probably unnecessary prototypes could have been avoided, saving you time, saving you money, and you end up getting your products out to market a lot faster, and probably at the same time mitigating the risk of products failing at some point down the road. But really, with all these things together, the most important thing is that we're creating better products. It's beginning with innovation in the early stage of the design, you're optimizing it through the detailed design, and finally here, you're validating using the high fidelity analysis that you do run through with Creo Ansys Simulation.
That's a great point, that last one, because we are trying to help our customers build better products and solutions. And while what's great about this tool is you're putting simulation capabilities in the hands of your designing and engineering team, and not every company has a expert on staff that is, FEA expert or a CFD expert. And Creo and PTC's come up with these great tools like the Ansys extension tools that put these tools in the hands of an engineer and a designer, so they can see what these results are going to be early in the design stage, so it doesn't have to be reworked downstream. So whether you have an expert on staff, if they get that file downstream, the work's already going to be done. They're just going to validate everything that the design is good. If you don't have an expert, then this becomes the expert for you, and this helps you make a better product. So another question that came in is this module locked to a license of Creo, or can it float and be pulled into any Creo license?
Yeah, good question. And it could be done either way. You could have it locked to an individual Creo license, or you could have a floating module that can be pulled in from multiple licenses.
Excellent. So I'm going to share my screen for a second. And one of the things that I just want to notate is that for our customers, we provide 2 hours of desk side coaching. It's actually 1 hour for every license of Creo that you have, but we do a minimum of 2 hours to help our customers better understand Creo and what their needs are. So if you buy this extension, one of the Creo analysis or Ansys extensions, we can help you get up and running quickly and help your team become proficient as quickly as possible in adopting the software. I mean, our goal is that if you're able to use the software, then you're able to get the value out of it a lot faster. And we have I think one of the foremost experts on the East Coast in finite element analysis and CFD. His name is Bill Stickney. He's tremendous, and he does a lot of simulation work for our customers. And he's just, whether it's linear or nonlinear analysis, he's fantastic. So if you're a customer, take advantage of this. If you're not a customer, become a customer, and we will gladly help you. So I want to thank everybody for attending. If you need any additional information, you can just reply to the email that you received inviting you to this webinar, or you can just email us at info@3hti.com. Next week's webinar is going to deal with something that is in the base license of Creo. It's called the Design Exploration extension. This is a tremendous extension that helps you to create iterations and ideas from a single Creo file without having to make multiple files and multiple iterations. So this is a tremendous tool in Creo, and I think a lot of people don't realize that it's there, or they don't spend the time to really play with it to see how it can save time and also reduce the amount of files that you have. So you'll be seeing the invitation on that very soon. So Paul, thanks again for your help today. This was a great webinar, and I want to thank everyone for attending. And we look forward to seeing you next week. And once again, if you need anything, please reach out and contact us. Take care, everyone.